Hello, welcome back to my channel with a new video. We're still going to talk about best practices for physically designing your database or your data store, looking at things from a relational structure and through data models. The problem that we're trying to address through modeling today is how to resolve a multiple entity relationship. Now, this is the best way I can use to describe this. You may have a better way of describing it, but let me explain to you what the problem is. So, the Daisy Hill puppy applications right now only allows a puppy to have a kennel as the puppy's owner. As you may very well know, sometimes a kennel owns a puppy and sometimes an individual person owns a puppy. And the way that it's dealt with now within the Daisy Hill applications is that if an individual owns the puppy, the attribute is simply left null, and we're left to not understand who that individual owner is. And so the question has been presented is to allow the application and then reporting downstream to understand and define the ownership of puppies by a kennel or by a specific individual. This causes a problem because kennels should be, and typically are, a different entity than your person entity, where you would keep individuals. You could also do some other things such as create an owner, but if you create an owner, then you've overridden what the kennel is because your kennels exist without being owners. The developers were not sure how to modify this. They had some ideas, and we bounced them around, and I showed them some different ways of designing what their ideas were so we could lead our way through to a better solution, understand how a good design would be more robust as well as more extensible. But there are other structures that you can go ahead and utilize to implement this as well, because at an application level, it's quite easy to program around a not perfect database design because the users don't see what you're doing inside of that application. It just makes the application a little bit tougher to write and to debug. And I posed one more thing to the developers and to the business people is that within the current construct of what we had inside of the applications, as well as what the definition and understanding is that a puppy can only have one owner. But I said, what happens where if a consortium or something else owns a show puppy that will be taken to shows, win prizes, and then go out to breed? And they said, well, when that happens, they just choose the primary owner or kennel and only carry that one through within the applications. And so it would also be helpful if we'd be able to handle the multiple relationship to where more than one kennel or more than one individual or a combination of kennels and individuals can own that puppy together. So we're going to look at a couple of different ways, or actually quite a few ways that we could resolve this and talk about the pros and cons of each design and to see which one fits best with your application ideas as well as what your reporting needs are. And along the way, we'll talk about the common modeling technique of supertype subtype, which really doesn't apply to this problem, but you could see it as a potential solution and work on things from there. So let's begin our best practice design of resolving this multiple entity relationship between puppies and the different owners, such as a kennel or an individual, or just really a consortium of owners as well. So our first idea is to go ahead and look at the current data model that's out there. I've used this in some of the other applications. And again, we've restricted this down to where all that we have is just the kennel and the puppy. And this is what we currently carry inside of our data model as well as the applications and our reporting. You have a puppy, and that puppy has a kennel that it's related to, owned by, or resides at. So there's a relationship between kennel and puppy, and obviously the kennel can own multiple puppies, but in this case, a puppy can only be owned or managed or reside with a single kennel. So we have the kennel ID in the puppy table from the parent kennel. So modifying this, let's first look at what developers usually like to do with their application, and that is to overload the kennel entity with an individual. And to do that, we will go ahead and pull in our modeling tool. I've already modeled the individual tables. I'm just going to bring them in and let you see what we want to do. So to do this, we're going to have to change our puppy. So let's go ahead and look at our tables, and we'll bring them in as we need them. As you can see, I've created quite a few copies of things. For in this instance, we're going to be looking at solution number 1, and we'll go ahead and we will bring in a different puppy. As you can see, this is the standard puppy that we had used in previous versions. Oh, sorry, we brought in puppy 2. Go away, puppy 2. We want to bring in puppy 1. There's puppy 1. So here again, it's sort of our standard puppy, just like it is in the default puppy table, but we're creating a slightly different relationship, so we wanted to create a different puppy table. So what we want to do is create a new kennel table, and we'll call that kennel table 1, and bring that into our model. And what we've done here to overload this is that we have this standard kennel table with kennel ID. We put an attribute in here, which is the owner type, so we know whether or not it is actually a kennel or it's an individual. And then we have the name, and this is the owner name for the individual that's there. And so what we will do then is inside of this kennel table, we will store both kennels and individuals that we're doing business with. This works quite well. You just have to know what the owner ID, owner types are, what the code is for that. Make sure that when you're looking at things, you query through it. But the problem here from an overall design standpoint is that, well, now you have a kennel table that is both a kennel and a person table. It would be nice to have that person. That's the con of this. The pro is it keeps things pretty simple and pretty straightforward the way they are. Solution number 2 is what's called optional relationships. What we want to do here is have both, and we'll go ahead and take these out. We want to go ahead and create that person table. So let's bring in puppy number 2. Which is a slightly augmented puppy table. And we'll bring in our kennel table because it does not need to be changed from our original design of a kennel. So this is our standard kennel table that we've been working with. Is kennel ID, kennel name, owner ID, and it simply is a parent to puppy. But you'll notice that right here when we define this relationship, we have a little small o here at its beginning as opposed to the solid line, and that indicates that there might not be a kennel ID associated with this puppy. And so we allow it to be a null field, which means if it is null, it is not owned by a kennel, and we need to look elsewhere. And so for that, we go ahead and we create our person table. The person table has slightly different attributes associated with it. It has first name, last name, and middle name, and a person ID, and it is also a parent, potentially, of the puppy table. And you can see that the relationships allows for nulls because the puppy might not have a person. So when you're actually querying this table and trying to do some data with it, you have to look in both kennel to see if a kennel owns it and in person to see if a person owns it. What you have to do then from a querying standpoint, the pro of this is we have a standard kennel, we have a standard person, they have a relationship with puppy, it's very relational, it's very standard. That's not necessarily the best solution because the con is that we have got two relationships, one which should be true and the other one should exist and the other one should not exist or be null. And we have to assure that we only have one of these relationships and not both of these relationships. And then within our queries, we need to make sure that we can differentiate between them and only present that piece of information associated with the person or the kennel, depending upon who owns it, and take those nulls out of there. So After the optional relationships, again, not my preferred solution, we want to talk a little bit about the supertype subtype. What this means is that there is a supertype associated with a parent table, and then there are subtables within that definition, usually through a relational standpoint. There's a couple of ways of resolving supertypes and subtypes within the database design standpoint, but essentially, if you want to think about the more purest case of supertype and subtype, we look at vehicles is a kind of standard one that we talk about. So you have vehicles, and vehicles all have some common things associated with them. But when you're talking about a vehicle that you own, you might own a car, you might own a plane, and you might own a boat. And so therefore, what you have is vehicle being the supertype and with some basic attributes associated with all of the different types of vehicles. And then the subtypes would be a plane, a boat, or a car, and those would be the relationships associated with that supertype. And then the supertype then has a relationship typically with the child table, and we go from there. So in this case, what we want to look at just from the supertype subtype, we're going to go ahead and bring in a new table called owner because this is our supertype. So basically we have owners. An owner has a type because it's a supertype. It has street address, city, and state code, so we know what it is. And then what we would create is a puppy table associated with this. Down here is our puppy table. And so the puppy table then is the child. And as you can see, it has an owner, either being a kennel, or in this, what would be being any of the subtypes. In our case, we'll be doing subtypes of kennel and person. So this makes a very simple relationship here, so we can see information about the owner. If we want to find more details, this owner type code will tell us how to go ahead and find what the subtypes are. So what we want to do is go ahead and bring in our kennel as the one subtype. And you see then what happens is kennel is a child of our supertype or owner. It carries the owner ID through, and it has a kennel name and the kennel owner name. And we would do the same thing with the person table. It is also a child of the supertype. And it has a first name, last name, middle name. Their addresses all put in a supertype because that's a common element associated with all of them. If you notice from a relationship standpoint, it shows you that there's a 0 associated with the kennel and the person within that crow's foot relational diagram. And what this says is that an owner may not have a person, or it may not have a kennel. And so again, from a query, from an implementation standpoint, this is pretty simple to do. It makes this relationship straightforward and easy to manage and manipulate. This relationship here simply becomes a little bit more complex, and we go on from there for our queries and our reportings and from the application development. Now, one of the negative sides of the supertype subtype is that this kennel is now a type of owner. But what happens if the kennel is not an owner? Or what happens if the person is not an owner? Do we want to have just simply person owner table and a kennel owner table? Or do we want to use that person table for more things? So that's the kind of direction that we want to go in. So we just really don't like this supertype subtype solution as being the best solution for what we're trying to do. But it is a solution, and if your application fits within this and it makes sense for you to report from it, that's what you would want to do. So let's go ahead and take a look at a new entity with children. And this allows us to get into this multiple range. So then rather than have it a subtype and supertype, what we want to do is go ahead and create a new entity. And this isn't much different than the supertype subtype. As we hide these from here, it's just simply a slightly different instantiation of the supertype subtype, but allows us some additional practical usage. So we slowly remove all these from our data model. So let's go ahead and bring in our new entity. We want to call this entity the business unit. So we created a basic business unit. This way, this allows us to deal with that multiple relationships, and whatever this business unit is, it can include multiple kennels, it can include multiple people. It's a better definition of what that business unit is and allows us to apply it in other relationships throughout our database, provided that we manage it. And for that, we want to go ahead and make sure that we bring in our person and our kennel table. So what we have now is this business unit, where within that business unit, we define any kennels that belong to that business unit. We define any people that belong to this business unit. And then that business unit has its own information as far as address, etc. So these are to a degree independent of that business unit, but all of them belong to at least one, if not more than one, business unit. So that allows us to more specifically define our kennels and people, and then associate them to this business unit. So we're fleshing out into a more realistic model. And then all that we need to do is to drag our puppy in here as well. And now that business unit becomes an owner business unit for the puppy. So it's not the direct Subtype subtype, because the relationship is that you can have multiple kennels or multiple people associated with this business unit, and it gives us a better understanding of what is happening within the application and within our family of data. But the con to this is that, again, we have kennels associated with business units, and we have to manage this data the way it exists. And what happens now if you have multiple kennels? You would have to repeat the kennel to have it reporting to different business units. So it is not the perfect solution. It's not necessarily any better than the previous ones, but it's just simply a better way of presenting this piece of data. So looking at the better solution from a data modeling standpoint and overall data constituency, it is what I would prefer to do if I had my choice of this data, and it is the many-to-many mapping tables. As we remove what we have out there again, cleaning up these just so we can show them being built. As you can see, some of these solutions that are more viable from a database standpoint we seem to be adding more tables into our solutions, which is one of the reasons why overloading a single entity tends to be the developer's choice as well as a reporting person's choice, because they only have to deal with one table. But to really understand the relationships and to carry that relationship information forward and give you more functionality, you tend to create a little bit more complex system. So if we look at going back into this, we're going to actually turn this relationship a little bit on its head from what we've done before. So first thing we're going to do is we're going to go ahead and bring in puppy. I'm calling this puppy X because it is my preferred solution. Should I be allowed to do this for the application standpoint? As you can see, it does not have kennel ID within its definition. It simply has identified the things that are on unary, such as breed, and really are related into that puppy directly. And now we're going to go ahead and bring in one of our previous kennels. This is our clean kennel definition. That's our owner kennel type. Ah, yes. we actually just want to bring in kennel because we're not going to change it from our basic definition of what we understood from our previous exercises. So the kennel table does not need to change to have this new structure built, the many-to-many relationships. And the person table is just a person table, and it doesn't have to have understanding of this new structure either, because what we have is that we want a kennel to exist independent of a puppy and a person to exist independent of the others as well. And we want to allow a kennel to be owned by multiple puppies, as well as a puppy to be owned by multiple kennels and or people in the person table. So what we want to do now is to create this mapping table. And you typically give it a name that defines what it is that it does. And in this case, what we have is the puppy kennel owner table. There it is. Came into the middle. And we've defined it simply as being the intersection between puppy and kennel. It has the kennel ID and the puppy ID. This strictly is used to define the relationship between the two. So if I have a kennel, I can go find the puppies that it owns. If I have a puppy, I can go find the kennels that own it. And we want to go ahead and do the same thing for the puppy person owner. So now we have two cross-reference tables, or two mapping tables, that give us the relationship between these two entities, and these entities are allowed to exist independent of the data that is associated between them. Now this becomes the application data model, and also can become a reporting model should you choose to keep it in this fashion. However, if you look at this, this is not a dimensional model. And so if we have a dimensional data mart, we have to sort of extend out the basic understanding of the dimensional data mart modeling structures, because this is the real world, and this type of structure is not unique within the data warehouse world. And so they came up with structures that allow you to support the multiple owners and the multiple owner types as well. One of the negatives associated with this, as we wait for me to go ahead and clean up this workspace, this is again a online modeling tool that I use called SQL DBA. There's some things it doesn't do quite as well as others. Clearing up your workspace is one of them, but I typically persevere. So let's go ahead and look at something that we've been working on before from a data mart standpoint, and we had that puppy performance fact table. And in this case, we're going to go ahead and create a copy of it called fact X, because we need to add these other things in. To show you from a dimensional modeling standpoint, we'll bring in some of our other dimensions. We have our puppy dimension, and we have our trick dimension. As you remember, they surround the fact table. We just want these here for reference so you see what's going on. And so in order to create this many-to-many relationship between dimensions, we have to go outside of the data mart and build some additional structures. It's really the one-to-many structures. They just have a slightly different name and constituency. And what we want to do is call this the owner group dimension. And so we have this owner group, and this owner group goes ahead and defines the relationship or the dimensionality of the puppy. So we have puppy, we can go see that it has an owner group. The problem here is that you need to build this owner group by relating it to the kennel and person dimensions. And you would simply create an owner group for each unique instantiation of the subset of kennels and there we go. instantiation of kennels and people that you have. So as you can see here, I now have my kennel dimensions that we've used before. We've created a new person dimension, and now we have this owner groups. And so what we have to do is create what's called a bridge table in dimensional world to show that there is a intersection between these two dimensions that we need to use. And so we will then create the owner kennel bridge. It is a lot like I have to figure out where the owner kennel dim. It is hidden around here somewhere. Where did you go? Let's put the owner person bridge in here real quick. There's the owner person bridge. Let's figure out where our owner kennel bridge went to. There it is. So we basically create two bridge tables. Drag this down so we get a little bit cleaner view of it all. And this is the same as a mapping table, just has a slightly different understanding. We can add some contextual attributes in here to define what the primary owner is, or what all of these different owners are within this group. But again, we have our standalone kennel dim, our standalone person dim, and then we create a subset of these that belong to an individual owner group. So now we can go to the owner group and query to find out what kennels and people are associated with that owner group. The con of this from the data warehousing standpoint is the fact that you've added three tables that don't directly indicate any dimensions that you would want to query through, and you have to maintain this owner group by seeing the instantiation of what kennels and people belong to that group. From a maintenance standpoint, if the owner group changes, you create a new owner group and not just simply modify the cross-reference tables that are associated with it. So this is a few more tables than you would like to see from a reporting standpoint, but it allows you to stay within that dimensional model, which is only dimensions belonging to fact tables on a one-to-one basis. And the additional information is put into this extended structure, which is the bridging structure within the dimensional world. I myself don't like building these and maintaining these, but if you have that data and that's how you wish to maintain it or need to maintain it, it is the easiest way to do reporting and to keep your data clean and easily accessible. So there is the bigger model that we created for our reporting. As summary, what I want to point out is there is not a right or a wrong data structures. All of those data structures we have are relational. They are fairly clean. They're fairly extensible. They're not necessarily the best structure to use if you're given a more purist standpoint and want to maintain all of the rules of normalized relational databases, and that is having a table that has a specific entity associated with it and relationships being fairly clean and straightforward. The application developers tend to be the ones that mostly go ahead and violate the rules of normal databases, and because their application can enforce the integrity of the structures themselves, and so they can get away with a little bit more of a risky structure out there. Always try to get the best structure associated with the problem at hand within what can be done and how much time we have to do it in, what people can understand, how they can translate it. And so the ones that I tend to come up with provided with better flexibility. No matter what the structure is that's in the application, you have to give the same thought process going into your reporting structures in order to come up with a model and a design that match your reporting needs, because what the application developers did from a data structures design might not be the best solution for you to do from a reporting standpoint. And so you have to really think about and redesign some of the structures that aren't as tidy as you hope that they would be, and come up with a solution that best meets your needs. And in this presentation, I showed you a number of different ways that you could model your data that all would get the job done. I just showed you the pros and cons and which ones I find to be the best and would end up with it that way, given my needs. But it's a discussion to always have within the people that are using the data, people that own the data, and the people that are doing the development. As always, no matter what data structure you choose, document it so people know what you've done. One of the biggest problems with overloading an entity isn't the fact that it violates quote unquote rules of database design. It's the fact that it's not well documented and people don't understand that you've overloaded an entity or even overloaded an attribute. So creating good metadata and creating a good model and keeping them alive will help you move forward, and so everybody can understand what you've done and do their reporting and their development from it. As always, thanks for listening. I hope you subscribe. I hope you enjoy this. I hope you get some better ideas for how to manage your data, because real world data is never as clean and pristine as it is in the examples given for standard data modeling. If you have a specific modeling question or problem that you need to have addressed, drop me an email, drop me a comment, and I can take a look at what your modeling requirement is and propose some solutions that might fit your business and applications needs. Have a great day.